Hi everyone. Let us see this unit number 14. Unit number 14, correlation. So what is our structure of this unit? We are going to see what is the objective of this unit, introduction, what do you mean by correlation, and what are the types of correlation and correlation analysis and summing of this unit and keywords and terminal questions we are going to see. So mainly we are going to see the first one. What is the objective of this unit? So the goal of statistical data analysis is to represent the complex real world phenomenon from partial and uncertain observations. It's important to make the distinction between the mathematical theory underlying statistical data analysis and the decision made after conducting an analysis. So, correlation is one which studies the relationship between two or more variables. Correlation quantifies the degree of direction to which two variables are correlated. So, here we are going to explain the concept of correlation, and using the scatter diagram we are going to visualize the relationship between any two variables, and we are going to compute the simple and rank correlation coefficients between any two variables. So these are our objectives of this unit. Let us move on to the introduction of this unit. So, in the previous units, we have discussed the statistical treatment of data relating to the variable, only one variable only. So, many other situations, the decision makers need to consider the relationship between two or more variables. For example, the sales manager of a company may observe that the sales are not the same for each month. Is it obvious? So they also know that the company's advertisement expenditure varies from year to year. So, however, he must be interested in knowing the relationship between the sales and the advertising expenditure. So, if a manager could successfully define the relationship, he might use the relation to do better job of planning and to improve the predictions of yearly sales with the help of the regression technique for this company. So similarly, so a researcher also may be interested in studying the effect of research and development expenditure on annual profit of a firm. The relationship that exists between the price index and purchasing power, etc., the variables are said to be closely related if the relationship exists between them. In this unit, we discuss bivariate analysis of simple linear correlation, and simple linear regression will be covered in the next unit. So the word bivariate is used to describe situations in which two characteristics are measured on each variable or time. The characteristics being represented by the variables or on time. Let us see the correlation definitions. Correlation is a statistical measure that indicates in the extent to which two or more variables fluctuate together. So, a positive correlation indicates that extent to which the variables increase or decrease in parallel. A negative correlation indicates the extent to which one variable increases as other decreases. So it is a statistical technique we have that show either that is whether how strongly pairs of variables are related. Although this correlation is fairly obvious, your data may contain unsuspected correlations. You may also suspect there are correlations but don't know which are strongest. So, an intelligent correlation analysis can lead to a greater understanding of our data. So, here we are going to list out that types of correlation. So the first one is positive correlation and negative correlation, and the second one is multiple correlation and partial correlation, and the next one is a linear and a non-linear correlation. So very first we are going to see what do you mean by positive and negative correlation. So if you are considering any two variable, so if that two variables are changing in the same direction, that is, if one increases means the other also will increase. If one is decreasing means the other will decrease. So likewise, if you're having in the same direction, if the variables are changing, then it is called as positive correlation. So for example, advertising and sales, so these are positively correlated. So some other examples are height and weight, household income and expenditure, price and supply of the commodity, amount of rainfall and yield of crops. So, negative correlation is nothing but if two variables we are considering and they are in the change can be happened in the opposite direction. That is, one increases means other will decrease, and one is decreasing means other will increase. So, likewise, negatively correlated. That is, correlation is called as negatively correlated. For example, TV registration and cinema attendance. So, some of the examples of the series of negative correlations are volume and perfect pressure of perfect gas, and current and resistance, price and demand for goods. So, these are the things we have. So the next one is multiple and partial correlations. So partial correlations measures an association between two variables with the effect of one or more variable factored out. The partial correlation coefficients measures the net correlation between the dependent variable and one of the two independent variables. So, this partial correlation analysis seeks to measure separately the relationship between two variables in such connections. So, here, thus the subscript to the right of the decimal values denote the variable. Um, the correlation, so in the partial correlation, we study the relationship between the variables keeping the other as constant. Okay, so for example, we can have the yield of crop may depend on the quality of the seed, soil and fertility, climate, etc. So the correlation between the yield and the remaining factors taken together is a multiple correlation. Is it clear? So the correlation between the yield and the climate, keeping the quality of seed and soil fertility uh, is constant. Okay, that is an example of partial correlation. So these are the partial and multiple correlation. So the next one is linear and non-linear. So here the linear and non-linear is nothing but so when the ratio of the change between the variables is same, then that is the when the amount of change is one variable, but here a constant ratio to the amount of the change in the other, then the linear correlation is linear. For example, consider that the variables x and y with the following that is the values. If you have x, suppose x is taking the values as 1 2 3 1 3 5 7 8, and y is taking 2 6 10 14 18 means, so the ratio of the change between the variable is same. So if the amount of change of one variable is less than, it doesn't bear a constant ratio to the amount of change of the other variable, then the correlation is non-linear. So for example, the amount of rainfall is doubled means the yield of a crop is not necessarily doubled. So this is linear and non-linear. This is linear and non-linear correlation, the mapping we have. So the next one is a degree of correlation. So the correlation coefficient measures the direction and the degree of the relationship between the variables in one figure. So on the other hand, suppose if it is independent of the choice of both origin and the scale of observation, and also it is also independent of the unity of the measurements, and also it lies between -1 to +1. So these are the degree of correlation, as well as the property also we can have. So -1 to +1, it varies. So the next one is correlation analysis we have. So if X and Y have positive linear correlation and R is close to +1, and R value of exactly +1 indicates the perfect positive correlation. If X and Y have a strong negative linear correlation, R is close to -1, the correlation or value of exactly -1 indicates a perfect negative correlation Z. If there is no linear correlation or a weak linear. So here we are sum up this unit of here. According to the Carl Pearson's coefficient of correlation in this +1, on the other hand, if a variable changes in the opposite direction in the same proportion, the correlation is perfect negative. Its correlation coefficient is -1. So absence of correlation. If two series of two variables exhibit no correlations, no relations between them, or change in one variable doesn't lead to a change in the other variable, then we can firmly say that there is no correlation or absurd correlation between the two variables. The keywords we have positive correlation, negative correlation, multiple correlation, partial correlation, linear and non-linear correlation. So that now we can have the terminal questions of this unit. So here what is a correlation analysis? Explain the degrees of correlation, explain the types of correlation, etc. So here we have completed unit number 14. Thank you.